welcome to the lecture 20 in this course on noise control in mechanical systems, and I am Professor Sneha Singh from IIT Roorkee. So, we have begun our module on the human response to noise, and this is a continuation in this module where we have the lecture 20, which is noise and human health. So, a quick summary of what we have studied till now in this module. So, we have studied about hearing, which is essentially the subjective response to sound by a human ear. Then we have studied about some subjective measures such as loudness and also the equal loudness contours, which say that our perception of the level is not just dependent on the decibels or the sound pressure, it is also dependent upon the frequency of the sound. So, that is what we have come to know, that loudness perception depends both on the sound intensity or the pressure and the frequency. Then we have also studied about something called as the pitch, which is a subjective perception of frequency, and then about sound quality and sound quality engineering. So, here we will see, because it is about noise and human health, so we will first see what is the status of occupational noise exposure across the world, and then what are the effects of this noise on human health. We will see both auditory effects and non-auditory effects, and one of the major auditory effect is the noise induced hearing loss, which we will discuss in detail. So, let us see, this is a summary of the research done on noise exposure in the occupational environment in India with the reference to the various papers. So, what you see is that in various industries such as textile industries, the range of noise levels in dBA is 95 to 100 and then 102 to 115. Similarly, in the pharmaceutical firms, again it is in the range above 90. In the fertilizer firms, oil and natural gas complexes at Bombay High, forging units in the various iron and steel SMEs. In most of these, always the noise level is above 90, it is sometimes closer to 110 or 114, which is an extremely loud noise and dangerous for human hearing. In the same way, what we have found in various critical industries such as the casting units in iron and steel SME, the stone crushing industries, the deep gauge hammer units, the hand tools in handicraft industry. So, this is just a summation of the research done in India, and where they have found the noise levels within the industry to be at a dangerous level, and such that the workers working in this industry are exposed to such dangerous noise levels and they suffer from hearing loss because of it. So, in most of these cases the noise level is touching 100 dBs and it is always above 90 decibels. Again, in the loading, crushing, compressor and boiler operations in various coal based thermal power plant, again the noise level is above 85. In the pulse processing units, cotton ginning industries, rice mills and various grinding units of the flour mills, in these food processing companies as well, sometimes the noise level is above 90 and in fact above 100 or 110 decibels even during certain operations. In the same way, if you look at the research done worldwide and try to see what is like the typical noise levels in the various industries. So, since India is still a developing country, so in the developing country the problem of noise pollution is heightened, as you can see with this extremely high sound levels recorded in these various industries. And in the worldwide, even in some of the developed nations also, the noise level is reaching at a dangerous level, such as in the olive oil mill industry. Although in certain operations the noise can be low as 74, but in certain operations when the milling machine is going on, it can reach above 100 dBA. In the same way, in the aerospace industry, the noise can sometimes reach up to 106 dBA, and these are the various countries over where this kind of research has been reported. Similarly, in the cement factory in Iran, this kind of noise levels have been seen, And then in the construction industries in various countries like Australia, Malaysia and Netherlands, what you see is that the noise levels can sometimes, it starts above 70 and can sometimes reach beyond 90 and up to 100 and even 140, which is, you know, the deafness happens. This is a dangerous level for ear, okay, very dangerous level for the human ear. So, even in these countries it is happening, and then automobile industry in the US, they are also. So, the reference of the various papers is given here, and what you see is that the range of noise level is somewhere between 85 to 114 dB. Even in the smelter plant in Canada, you can, it has recorded here the noise level is less than 90 dB, but still it is at a higher range. And then in the metal industry in Egypt and South Korea, you see an extremely high noise level, very dangerous for human beings. In the mining industry, again 90 decibels of noise has been recorded. In the auto part factory in Thailand as well, sometimes the noise is above 80 and reaching up to 95 or 97. So, what you see is that in various industries such as the shipyard industry in the Sweden, again the same phenomenon is seen. The noise levels are usually above 85 decibels and they are reaching close to 95 to 100 decibels. And in the other various industries, similar observations have been made in some of the most developed nations as well, such as the Scandinavian countries like Finland, then Denmark, Japan, even some of the industries, they are recording high noise levels despite the measures being taken till date. Aircraft manufacturing is also recording in the same way in Taiwan. The sawmill industry in Canada is recording above 85 decibels of noise, and this is the dBA noise, which is the A weighted decibels, and usually the A weighted decibels for a machinery, for typical machine resources, the A weighted decibel is usually lower than the decibel level. So, this is not like dB would be even slightly higher compared to the A weighted decibel levels for the machinery noises. So, what you see from this is that in the various industries and various such occupational environments, the workers and the employees are being exposed on a daily basis with such high noise. And considering that these workers are doing an average of 8-hour shift per day, now we need to find out that okay, how harmful this noise exposure is to these workers. So, a measure that has been defined for this is called as the noise dose. So, it is similar to, like, for example, suppose a patient is given a medicine and they are given that this is the recommended dose of the medicine, you do not exceed it, otherwise it can have side effects. In the same way, the noise dose can be viewed something similar to that, where the workers who are going into these noisy occupational environments and considering that they are doing an average of 8-hour daily shift, the dose or the net exposure they are getting to the noise should not exceed a certain level. So, a measure has been defined. What it indicates is that this measure is that what is the daily noise exposure of a worker in an 8-hour work shift, and whether this daily noise exposure is exceeding a hazardous level or not. So, usually we are using the symbol capital D for this particular measure, which is the noise dose. We can also say that it is the amount of actual noise exposure that is being done on a worker relative to the amount of maximum allowed noise exposure expressed in percentage, considering that it is the worker is doing an 8-hour work duration. So, the formula for this is that D is equal to C1 by T1 plus C2 by T2 and so on till Cn by Tn into 100. So, what it means here is that here all these Ci's or Cn's, these are what? This is the total time of exposure at a specified noise level, and Tn is the maximum allowed exposure time beyond which the noise for this level will become hazardous. So, WHO, and then there are various other institutions such as the National Institute of Occupational Safety and Health and various other institutions, what they are doing is that they have recommended based on the years of research with human beings, they have come and they have made some recommendations that if suppose within an occupational environment a worker is exposed to, let us say, some level L, then the maximum time of exposure should not go beyond a certain time t. Otherwise, it will be hazardous and dangerous for the worker's health. So, some recommendations have been made on what is the maximum allowed time given a certain level of noise. So, with a common sense you can say that, higher is the noise level, the lesser would be the maximum time that should be allowed where the worker can be exposed to. And this is the actual exposure and this is the maximum allowed exposure at that level and so on, and multiplied by 100 it gives you in percentage. So, which means that if D is greater than 100%, you have over exposure, worker health is compromised, it's hazardous. Whenever the noise dose becomes more than 100%, which means more than the recommended exposure. So, let us see, and here it is for an 8-hour work duration. So, this here the summation of all the time has to be 8 hours. Okay, we are calculating it for an 8-hour work shift. So, let us see some of the so let us see what is this T and what are the maximum allowed exposure time for a particular occupational noise level. So, based on the National Institute for Occupational Safety and Health, so you have two internationally people either use the National Institute for Occupational Safety and Health guidelines, or they use the OSHA guidelines, which is the occupational which is the OSHA guidelines, the Occupational Safety and Health Administration guidelines. But this guideline, the NIOSH guideline, is stricter than the OSHA guidelines. So, here I have given the more stricter guidelines, which is the NIOSH guidelines. So, based on that, suppose if a worker is doing an 8-hour of shift, then 85 decibels is the maximum allowed exposure time, considering that the worker works 5 days a week with no exposure to any noise in excess of a C weighting of 140 dB. Because if it is 140, suppose you are giving silence or you are giving the worker 60 decibels or 70 decibels and suddenly there is an outburst of 140 dB or above, the ear will be damaged. There will be a permanent damage to the human ear and there is no point then. It is going to be hazardous even for a small instant of time. So, considering that the noise never exceeds 140 or above and there is an exposure, then for different levels there are different exposure times and vice versa. Suppose this is the exposure time, this should be the maximum level, and if this is the level, then this should be the maximum exposure time and so on. Now, what you see here is that as you are increasing the level, the exposure time is going down. And what is the formula? If you see that every plus 3 decibels you do into the average noise level in the occupational environment, the maximum exposure time reduces by half. The maximum exposure time to that level reduces by half, and vice versa. If you reduce by 3 decibels, the maximum exposure time will double. Okay. So, for any level, if you have to find out what is the maximum allowed time beyond which that level or that noise exposure is going to get hazardous for the worker, then this could be a generic formula. So, Ti is equal to 8 by 2 to the power Li minus 85 by 3. So, this is the reference we take. 85 decibel corresponds to 8 hours. So, if you see here, if the level that the worker is being exposed to is 85 dB, then the time for 85 dB would come out to be which is 8. In the same way, if it is 88 dB, which is 2 to the power 3 by 3 or simply 2 to the power 1. So, it becomes 8 by 2 or 4 hours. This is in hours. Okay, it is not the SI unit, but it is in hours. In the same way, suppose it is T Let us take for example, we reduce it. So, let us say it is 82 dB. So, it becomes 2 to the power minus 1 or 8 multiplied by 2, it becomes 16 hours and so on. So, in this way you can find out the various values. Okay. So, let us see a sample problem on how to calculate the noise dose for a worker. So, let us say suppose a worker is being exposed to the following noise levels in a working shift. Rather than a day, I should call it a working shift, because it is not a 24 hours monitoring, it is a 8 hours monitoring only during that work environment. So, here these are the levels and this is the duration. If you sum it up, the total duration comes out to be 8 hours. If it is less than 8 hours, noise dose is for 8 hours. So, you just consider that the remaining time is less than 80 dB or 85 dB, and you find out if it is more than 8 hours, then again some readjustment needs to be made. So, let's calculate this problem and see what's the noise dose like. So, here this is the level given and the exposure duration of the worker given. So, these are the various CIs or the actual exposure times, and the maximum allowed time for a level are the TIs, which is for 85 8 hours, 88 it is 4 hours, 91 it is 2 hours and 94 it is 1 hour. You can calculate it using this formulation. Then what you see here is that 100 multiplied by CI by TI. So, 4 by 8 plus 2 by 4, okay, plus 1 by 2 plus 1 by 1. So, if you do it, you come out with 250 percentage. So, this means what? That this means that the worker is being exposed to 250% of the NIOSH recommended noise dose, which indicates an overexposure and overexposure to these hazardous noise levels. It is dangerous for the worker. Now, if you notice here, let us say, here in the first two exposures, the worker is being underexposed to the hazardous noise level, because the actual exposure time is just half of the maximum allowed, and only in the last exposure. So, for the first three it is happening like this, but only in the last exposure it is reaching the maximum allowed time. So, basically in no exposure the worker is being overexposed, but still we are getting a 250 percentage. What it means is that this noise dose is not just dependent on the exposure times at some levels, but it is also dependent on the number of exposures. So, basically if you would have done only these first two exposures, you would have gotten 100% and it would not be an overexposure. But again, if you increase one more exposure or you vary the different levels, it starts becoming dangerous. So, even exposure to these varying levels have been given a weightage and you are getting a high exposure. Now, let us see, now you see that okay, in general what you observe is that people are being exposed to high noise, high levels of noise, sometimes reaching above the hazardous levels. For example, here for a work shift 85 dB if you consider, then most of the research that I had indicated, almost in all the companies the levels were hazardous for the worker. So, which means that noise is definitely an issue, and what is the effect it is actually happening on the human health. So, what is the effect of noise on human health? We can divide the effects of noise on human health as auditory effects and non-auditory effects. Okay. In the auditory effects, you can have various things related to the sensation of hearing and the ear organ as such. So, you can physically feel pain in your ears sometimes when you are listening to heavy noise. In fact, what I have personally experienced is that if you have bad headphones or bad earphones and you are listening to some some kind of rock music or some kind of music, and for a long duration, even that causes a pain in my ear. So, pain in ears happen. Then there is an issue called as tinnitus. What do you mean by that? Is that it is where people, after being exposed for a while to hazardous levels, a condition develops. It is a hearing disorder where what happens is that you sort of, you say that my ear is ringing, I can see my ear ringing, even though there is an absence of stimulus or there is an absence of sound, even then your ear senses some kind of ringing noise. Okay, that is a tinnitus. Then the damage can be caused to ear anatomy, such as the damage to the inner hair cells, the swelling of the eardrum, various kind of these, and all of this then if there is damage to the physical ear and its various organs, it can lead to an increase in the threshold of hearing, which means that deafness can start, which means that somebody, a normal person might be able to hear a particular sound at a low decibel, whereas for the other person they are not able to hear it because for them it is too low. So their threshold of hearing has risen up. Okay, somebody who is able to, let us say, listen to a sound as low as 0 dB or 10 dB, but for a person in which hearing loss has started, that same person, they can only hear a sound beyond 40 dB or 50 dB, let us say. So this thing together becomes the hearing loss. There is a damage that is happening to the ear anatomy and the threshold is rising, and if there is permanent, it becomes a permanent hearing loss. So these are some of the auditory effects. I will just write etc. here, which means that obviously there are various effects related to auditory effects, and we are not, it is not possible to cover each and everything. So we are just giving some of the common auditory effects and etc. In the same way here also I will just add etc. So then we have the non-auditory effects. The non-auditory effects can be divided as, I would like to divide it as physiological effects, mental effects and emotional effects. So let us see what are these non-auditory effects. In the physiological effects, obviously it is related to the physical mechanism of your body and the biology itself. So you can have various things like high blood pressure, fast pulse rate, sleep disturbance, some abnormal heartbeats and various other kind of cardiovascular disorders, etc., etc. All of that, palpitation, then perspiration, all of these things come under physiological effects. Then their mental effects, it causes headache, it can lead over time to memory decline, and all of this is due to chronic exposure. I will say it is not like you listen to a loud noise, suddenly your memory declines. These are chronic effects, which means very long term continued exposure over a long number of periods or long number of years can lead to these kind of effects, which is the memory decline. Chronic long term effect, not immediate, this one. Then these are the immediate effects. Immediately you are listening to a loud noise, it can lead to headache. In the same way, difficulty in performing cognitive tasks, very simple. As a student, as a industry professional, we are all we are involved daily in cognitive tasks. We have to use our brain, we have to solve problems, we have to be involved in mathematical tasks and lot of computational tasks and problem solving. So all these cognitive tasks, they need a lot more focus and attention, and noise can definitely disturb in performing these cognitive tasks and disturb the concentration. Some of the so all of this is related to your brain and how it's sort of hampering the brain activity. So I have classified it as the mental effects. Then you have emotional effects, because noise can, that let us say, suppose you are an avid music listener. So noise, the sound, that it can uplift your mood or it can degrade your mood. So noise plays a lot of role in how you feel about in a day. It can, listening to some music can cause anger, listening to people abusing each other in the internet or whatever, in the social media you have lot of noise and abuse, people are talking abusively or shouting. It can create a certain, it can sort of create certain feelings within you, you will not feel all right. So noise definitely is directly related to how you feel and what emotions you feel. So emotional disturbances can be caused, stress is caused, anxiety is caused if there is lot of harmful noise around. You get annoyed, you have mood swings and all that. Listening to a pleasant music or a classical music can uplift your mood, and listening to people shouting at each other and abusing each other can definitely cause anger within you. So, these emotional effects happen. So, within the auditory effects, because that is something which we will discuss more in detail now. So, again all of this I have added the etc., there are many other things. So, here in the auditory effects you have immediate loud. What happens when there is an immediate exposure to loud noise? Here what you have, either temporary or permanent impacts happen depending on what is the intensity and the duration of the sound. So, suppose you are immediately exposed to a loud noise which is, let us say, less than 110 dB or something, you might feel like suddenly there is pain in your ears, headache or ringing or whatever, but all of that is temporary because it is just an immediate exposure. Later it subsides down. So, there could be temporary threshold shift, but if it is above 140 dB, even immediate and one time exposure can cause damage to your hearing, which could be a permanent damage. Okay. In the same way, long term or continued effect, which is called as the chronic exposure. So, either it could be an immediate exposure, it can be long term continued exposure. So, if you are being exposed to high noise levels for a long term or chronic exposure, even lower levels, which are, let us say, even lesser than 100 dB, can be very harmful. It has more severe and permanent long term auditory impacts, and it can lead to things such as noise induced hearing loss and permanent shift in the threshold of your hearing. So, what is the threshold of hearing? Threshold of hearing we have already discussed when we started in the beginning lecture of our human response to noise, where I was showing you the equal loudness contours. So, basically what it means is that it is the minimum sound level at which it is just being heard, and usually what you see is that in the equal loudness contours, what you saw, that most of our loudness contours are like that, and then somewhere here, which I can indicate with a different color, is your absolute threshold of hearing. You can refer back to my previous lectures where I am discussing about equal loudness contours, where we have discussed about absolute threshold of hearing, which means that it is the minimum level for a healthy human ear. What is the minimum level at which the absolute threshold means that is for a healthy ear which is not suffering from any clinical problem. What is the minimum level at which the sound is being heard, and this obviously is dependent on the frequency. In these mid regions it is more sensitive, so you are able to hear even lower decibel of sounds, and in the higher frequency this sort of increases up. So, threshold of hearing becomes at minimum sound level. So, the main auditory effect which happens due to these exposures, whether immediate or long term, is that our threshold shifts, which means that after noise exposure the hearing threshold, it increases for a short period of time, then it is a temporary threshold shift, and then it will recover back to its initial level. Then the other kind of threshold shift would be the permanent threshold shift, which means that after noise exposure the ear does not fully recover, and the threshold here increases permanently, and there is no recovering back or returning to its initial level. Let us see what is temporary threshold shift. Let us say, for example, you had your first experience in a flight, and after coming from the flight you feel weird, because your ear is feeling weird, you are not able to sense all kind of sounds, but it does not mean that you have become deaf or your ear has suddenly changed, your hearing pattern has suddenly changed. It is just an effect of your first flight that you had, and once you came back, within a day you recover and you retain your original hearing. In the same way, let us say you went to a concert, and in the concert we enjoy loud music. So, lot of amplifiers are there and you are sitting in the first row, and suddenly after the concert you might feel that after this loud 2-3 hour sessions of this loud noise, when you come back, the low volume sounds you are not able to hear it immediately. So, that does not mean you have become deaf, that just means that there is just a temporary shift in your threshold. Temporarily your threshold has risen to a higher decibel level, so that lower levels you are not able to hear, but slowly it is going to regain and return to its initial level. So, Here you can see this is a temporary threshold shift which happens, let us say somebody is exposed to a broadband noise of 150 decibels for 20 minutes, after which they are just left. So, what happens after immediate exposure? This red curve shows that 30 seconds after the cessation of the noise exposure. So, just 30 seconds after this exposure to the loud 115 decibel noise at 20 minutes, this is your absolute threshold that has been recorded, which means that the minimum level, and at the various frequencies what is the minimum level that you can just hear. And as you can see, your threshold has sort of increased in value. Okay. So, the absolute threshold should be 0 decibels throughout. This could have been the absolute threshold, but it has gone down. So, basically it has increased in value. You are not able to hear the sound below 50 dB in this case, and here below 40 dB in this case, but after 15 minutes suddenly the new threshold that is recorded is this. So, we are doing hearing test. So, this is a research from this website, and they did hearing test after different time periods post the noise exposure. So, after 15 minutes of the noise exposure, you see that this is a threshold. So, suddenly the threshold is going back to the normal state, and then after 5 hours it is further shifted to the normal state, and after 24 hours it is almost regained the actual hearing status. So, what is noise induced hearing loss? This term was introduced while discussing about the auditory effect. So, this happens due to chronic exposure. This is a chronic exposure, this is not a exposure to immediate levels, or this is not related to, and this is the permanent shift in the threshold. This is not also related to temporary threshold shift. So, noise induced hearing loss, as the term suggests, is pretty straightforward. It is a permanent hearing impairment. Okay. So, the word permanent, it is not temporary. All the examples I gave just now of being in the concert, taking your first flight, they do not qualify as a noise induced hearing loss, because this is a permanent shift in the threshold that happens due to long term chronic exposure or an immediate exposure to extremely high level, okay, or immediate exposure to extremely high level. In any case, there could be a permanent loss in the hearing. Okay, so, this permanent hearing impairment, which is caused by the exposure to sound levels at certain durations that harm your ear anatomy. So, they harm the cochlea's hair cells, which are responsible for converting the sound waves into electrical signals sent to the brain. So, there is a permanent damage to your ear mechanism. And how do you evaluate the noise induced hearing loss? You evaluate it through audiometry, which is a standard clinical procedure for testing the threshold of hearing, and it finds the threshold shifts, and it also finds the speech intelligibility levels. We are going to discuss about this in this lecture, so on. So, this is the noise induced hearing loss. So, let us start with the audiometry, which is a standard test for measuring the hearing capacity of an individual. So, the first type of audiometry that is done is the pure tone audiometry, in order to find out whether an individual has suffered a hearing loss due to noise. So, again here I would like to say that this NIHL, as the name says, it is induced by noise. Okay. So, the permanent hearing loss that is happening caused by the exposure. Okay. So, suppose if some person is born deaf, okay, if somebody is born deaf, that is not NIHL. If some, and deafness due to aging. So, with aging all parts of your body slowly stop functioning properly. So, there could be, in the same way you lose your digestion, you lose your bladder control, you lose. So, basically various parts of body stop functioning, and deafness that is caused due to just aging also does not qualify as noise induced hearing loss, because this is not because of the noise per se. This is because of aging, and this is because of by birth itself you had a defect and you were not able to hear the sound. So, all of this does not qualify as noise induced hearing loss. Noise induced hearing loss is what? It is somebody who was healthy in hearing and should have been healthy in hearing given that age and that health status, and still because of being exposed to noise they lost the hearing. So, pure tone audiometry is done, which is a diagnostic test which is conducted by an audiometer, and it is used to measure an individual's hearing threshold across different frequencies, and you get a graph which is an audiogram. So, obviously what would this graph look like? It would be you are measuring the hearing threshold across different frequencies. So, it should be a frequency versus decibel graph. Suppose you start from 0 dB, 10 dB and so on. So, these kind of graphs you will get, what is the threshold across the different frequencies, and this is used for an early detection of hearing loss. This is a typical audiometer in our lab in the noise control and mechanics vibration laboratory. So, in this lab we have this audiometer. So, what you have, this is the device through which pure tone signals are generated at various dB levels, and the person whose hearing has to be tested, they can wear the headphones, and this is the response button where they can press the button as soon as they hear the sound. So, what happens, the participant is made to sit in a quiet and darkened room, which means that so that the participant is devoid of other stimulus and there is nothing that is distracting them from the hearing task. Then they listen to pure tones through the audiometer setup and the headphones. One by one, a pure tone at various frequencies and various decibel levels are given, starting from 0 decibel at each frequency and going higher in the steps of 5 decibels. And as soon as the participant is given that will start giving you the sound stimulus, and as soon as you hear it, you have to press your response button. So, let us say we started from the frequency 500 hertz. So, we give a 0 decibel of 500 hertz and then 5 decibels, then 10 decibels, 15 decibels and so on till the participant presses the button that they have heard the sound, and the minimum level at which they heard it would be recorded, and the responses would then be plotted as an audiogram. This is what it would look like. So, both the ears are tested separately, the right ear and the left ear, and their responses are recorded in this particular fashion. So, I think with this I would like to close this lecture and will continue our audiometry discussion in the next class. Thank you.